Good day, everyone. Today we are going to talk about glass fracture analysis. So, glass fracture analysis helps to determine the directions and angle of force that broke the glass, along with sequence in which the fractures occurred. Glass fracture. So, a glass fracture is when a force is applied on any surface of glass, it bends, but since the elasticity of glass is limited, ultimately it gets fractured after threshold force application. Significance and use of glass fracture. Fracture patterns are unique. Pieces from the broken glass pane or hole often show marks that are characteristic of type of injury and directions of force. If correctly interpreted, these findings gives useful information about the object used for braking and velocity of braking object. So there are scenario. There was a shooting incident that happened in a certain place. The random guy used a 9mm caliber pistol in firing, and it happened to hit the glass. Two bullets were found that left two holes and a fracture in the glass. Bullets are projectiles that can pass through glass. As bullet velocity increases, the velocity hole becomes smaller, cracking patterns become simpler, and the exit holes become wider than the entrance hole. So after the incident, we are going to identify which bullet hole was first or which fracture occurred first. First, we identify what type of glass is involved in the crime scene. So first, what is glass? Glass is an amorphous fusion of mineral compounds that produces a transparent solid when cold. The type of glass that we found in the crime is flat glass. A flat glass is made of a float glass process where molten glass is floated on. A pole of thin white cooling, commonly found in doors and windows. So after identifying the glass, we locate where the entrance side and the exit side are. So on this side, this is the entrance or the loaded side where the bullet entry. It is the entrance because it has a smaller hole, and this side is the exit or the unloaded side, where the bullet goes out. It is the exit because it has a wider hole. As you can see, there are cracks around the hole, and there are two types of cracks, the radial cracks and the concentric cracks. And the exit or unloaded side, we labeled each hole as bullet A and bullet B, and identify what types of crack is present. And by using the 3R rules, which means radial cracks forms the right angles on the reverse side of the force, we confirm that radial cracks are present in the unloaded side. So what is radial cracks? Radial cracks, when an object has been thrown through a glass pane, a fracture forming a pattern somewhat like a spider web will be seen. The cracks will appear radiating outwards from the point of impact, making a star-shaped fracture known as radial fracture. So the radial fractures originate on the surface opposite on which force was applied. This type of fracture is always the first to appear on glass. So in the entrance or loaded side, same with the other side, we labeled each hole as bullet A and bullet B and identified what type of crack is present. In this side, we confirmed that concentric cracks are present. So what is concentric cracks? A series of broken circles originate on the surface on which force is being applied around the point of impact. There are secondary fractures as they always appear after radial fractures. So therefore, we conclude that bullet A was shot first because as we observed in the radial cracks, there was a presence of earlier cracks that stopped the spreading of cracks caused by bullet B. So there are points to remember while analyzing glass fractures. Radial cracks are formed first, commencing on the side of glass opposite to the destructive force. Concentric cracks occur afterward, starting on the same side as the forced. As the velocity penetrating projectile decreases, the irregularity of the shape, the whole and of its surrounding cracks increased. Fracture always terminates at the exciting line fracture. Stress occurs on the edge of radial glass fracture. And that could be all